When we look up at the night sky, we see only a small part of what the universe hides. The part we can see is called the visible universe. And that's really all that our eyes or the most powerful telescopes can see. But imagine for a moment that beyond those twinkling dots of stars, there could be something else, something incomprehensibly great and mysterious. And that's where scientists enter the arena with their most exciting hypotheses about what lies beyond our cosmic horizon. Tonight, we're going to try to explore 5 of the boldest and craziest of them all. Brace yourselves. We are taking a journey beyond the visible to discover the unknown. We're talking about something that sounds like science fiction, but is actually serious scientific research: the Hubble sphere and the possibility of our cosmic twin. The Hubble sphere is the boundary of the universe beyond which objects are moving away from us at speeds faster than the speed of light. It's not that they're traveling faster than light. Rather, it's the space between them and their subjects that is expanding so rapidly. Now imagine that beyond this world, there is another universe with a planet like Earth and inhabited by someone very much like you. The science sounds crazy, but math and physics tell us that anything is possible in an infinite universe. If the universe is truly infinite, there must be duplicates of us out there somewhere. This idea is based on the assumption that if the universe is infinite and contains an infinite number of galaxies, then the combinations of particles that make up our world must repeat somewhere. Which means that somewhere in the vast expanse of space, there is another person watching this video, but perhaps in another universe. Of course, this is just a hypothesis and can't be proven yet. But it does encourage us to consider how big our universe is. Perhaps one day, when science reaches new heights, we will learn more about what lies beyond the Hubble sphere, and perhaps even find our cosmic counterparts. At present, we can only speculate and dream about the infinite possibilities of the cosmos. Now, we're going to talk about the most exciting and perhaps the most fantastic hypothesis: the multiverse hypothesis. Imagine that our universe is just one of countless coexisting universes. These universes could be completely different, with different laws of physics, different initial conditions, or even contain completely different life forms. For example, in one parallel universe, Earth could be a planet where the dinosaurs did not die out, but continued to evolve, becoming the dominant, intelligent life form. In another case, the gravitational constant could be so small that stars could not form, and the universe would remain a dark and cold place without light. According to the hypothesis, the multiverse can be divided into different levels. At the first level, there are universes that are just beyond our visible horizon, and in which the same physical laws that apply to us may apply. At the second level, there are universes with different physical constants. The third level represents universes created in the many worlds interpretation of quantum mechanics, where each quantum event creates a new universe. Finally, the fourth level. It contains all mathematically possible universes. One of the most interesting ideas of the multiverse. This suggests that some of them may have a version of us living a completely different life. Perhaps there is someone among you who has become an astronaut and explores distant galaxies. Or you, who never knew what the internet was. And now he's trying to club some wild boar for his evening meal. So, now let's dive into the world of parallel universes, which has recently been beautifully presented in the new TV series Dark Matter. This series, based on the novel of the same name by Blake Crouch, tells the story of a physicist named Jason who finds himself in an alternate version of his life. To get back to his family, he has to go through a series of parallel realities and face an alternate version of himself. This series illustrates one of the most intriguing ideas in physics and philosophy: the possibility of multiple universes, each of which is a reflection of the different paths our reality could take. In each of these universes, the story unfolds differently, depending on choices and coincidences that shape the unique course of events. The theory of parallel universes suggests that for every possible outcome of events in our universe, there is a separate universe in which that outcome occurred. This means that there may exist a universe in which you made another major decision that led to a completely different life. You may have never met your best friend in any of these universes. In the second, you invented something that changed the world. Stephen Hawking, one of the greatest minds of our time, has also contributed to the development of this theory. In his latest work, he proposed a way to solve the cosmic paradox of parallel universes and suggested that some of these universes may be very similar to our own. Dark matter shows how these alternate realities can intersect and interact, giving viewers a unique insight into how events might unfold if the past was different. It makes you think about how fragile and changeable our reality can be, and how small changes can lead to completely different outcomes. So what's going to happen? It turns out that each of us is the center of our own universe, and every choice we make creates a new story. Imagine you are standing at the edge of a vast, vast ocean. You can see the waves reach the horizon, but what lies beyond it? It's the same with the universe. We see stars, galaxies, nebulae, but what lies beyond the cosmic horizon? Maybe there's just nothing out there. This thought may seem strange, for how can nothingness exist? But in cosmology, nothingness necessarily means the total absence of everything. It could be a space without matter, radiation, galaxies, or nothingness in the absolute sense of the word. But even in this vacuum, there can be quantum fluctuations, virtual particles that appear and disappear in the blink of an eye. According to one theory, there may be an infinite void beyond the observable universe. This assumption is based on the fact that the universe is expanding, and with each passing second, the boundary of the observable universe is moving farther and farther away from us. If so, then perhaps there really is nothing beyond our visible horizon. No stars, no galaxies, no light. So when we talk about the possibility that there could be nothing beyond the visible universe, we are not talking about just anything. Let's talk about the limits of our imagination and how far we can look into the abyss of space. The universe is not only what we see, but also what we cannot see, and that every new discovery can completely change our perception of reality. This is why the study of space is a wildly interesting thing that keeps us constantly asking questions and searching for answers, even if those answers may not be to our liking or expectations. The dark flow theory predicts that clusters of galaxies in the universe are moving in a coordinated fashion in the same direction. This is not just random motion, but seems to be caused by some massive structure that is beyond the visible universe. Imagine that our entire cosmic home is drawn to an invisible beacon that we can't see, but can feel through its gravitational influence. This theory came about after analyzing data from the Sunyaev-Zeldovich effect. That allows us to measure the movement of gas in a cluster of galaxies. Scientists have found that these clusters move in a particular direction faster than could be explained by known gravitational forces. One possible explanation for the dark flow is the gravitational influence of objects outside the visible universe. There could be a supercluster of galaxies, or even an entire parallel universe that was connected to ours at the time of the Big Bang. This crazy hypothesis suggests that there may be structures beyond the visible that have a huge effect on everything in visible space. It's as if we've discovered that our universe is just one part of a vast cosmic archipelago, where each island affects the motion and fate of the others. The dark current theory has yet to be definitively confirmed, and scientists continue to study its effects to see if it really exists and what might be causing it. If the dark current does exist, it would be one of the most important discoveries ever. Let's talk about what could happen to our universe in the distant future. It's a story about how things might end up freezing rather than hitting. This is a theory known as the Big Freeze. Imagine a universe that continues to expand until no more stars are born and the last ones die out, leaving behind only dim dwarf stars and black holes. The temperature of the universe tends to absolute zero, and everything in it slows to a complete stop. According to this theory, the universe came into existence as a result of the Big Bang, but instead of eventually returning to its original size, it continues to expand forever. Over time, when all the stars have used up their fuel and no new ones are forming, the universe becomes dark and cold. Energy is distributed so evenly that stars and galaxies can no longer form. Interestingly, this process may not just be a slow decline. For example, scientist Christoph Wetterich hypothesizes that the universe was cold and fragile in the beginning, and that over time, key particles became heavier and the gravitational constant decreased. This assumption explains why our current cosmos is dominated by dark energy and why we see density fluctuations in the early universe. So, if the Big Freeze theory is correct, our universe may not be a boiling cauldron of stars and galaxies, but rather an infinite frozen void, like a giant refrigerator. Here, we have come to the end of our space journey to different parts of the universe. Together, we looked at what was visible beyond the boundary and allowed ourselves to dream about what might be lurking in those distant spaces. We've talked about multiverses, where any one of us could be anything, and a dark flow that may be pulling us towards something we don't understand. We have considered the idea that there can be nothing absolute beyond the cosmic horizon. We have even allowed ourselves to imagine that our universe is just one of an infinite number of stories unfolding in parallel worlds. Who knows, maybe one day we will be able to confirm these hypotheses or even discover new ones that will overturn our established knowledge. And while we wait for these great discoveries, let's keep asking questions, searching for answers, and enjoying every moment of our marvelous cosmic adventure. After all, curiosity is what makes us human and allows us to dream the impossible. We live in an age of great astronomical discoveries. Thanks to modern orbiting telescopes, we already know more than 5,000 distant worlds. Most of them are really amazing places, unique and mysterious, and sometimes even very dangerous. There are planets illuminated by the light of 2 or 3 lamps at a time, and there are those that are forever hidden in the cosmic darkness. Some of them are terrifying in their extreme conditions, and others are surprising in their unusualness. We've traveled to some of the most terrifying exoplanets in the past. It's time to continue your journey. Among a number of other worlds, special attention is usually paid either to potentially habitable planets with comfortable conditions and moderate climate, or on the contrary, very dangerous objects that stand out from the general background. However, there is a third category. These are anomalous celestial bodies that exhibit strange behavior that is sometimes difficult to explain scientifically. Such objects defy our knowledge and deserve special attention. and the next world belongs to them. 2009. The Kepler 413 system environment. An unknown object passes between our planet and a distant star, diminishing its brightness for a moment. Astronomers, who believe this event to be a regular transit of an exoplanet, report the discovery of a new celestial body. High-precision calculations can even determine its parameters. The planet turns out to be a cold giant with a mass of about 25 Earth masses and a radius about 40% that of Jupiter. However, the next expected transit did not occur until 180 days later. The planet, so clearly visible in the old data, seemed to vanish without a trace. The mysterious phenomenon can be explained by a dark spot in the photosphere of the star or a giant field cloud moving near it. But these hypotheses were completely disproved when, after 800 days, the mysterious objects returned as suddenly as it disappeared. The supposed planet eclipsed the disk of its parent star 5 times before disappearing again. However, a clue has already been found. It turns out that Kepler 413b's orbit is very unusual. The celestial body is near the double focus and is 0.36 AU away from the common center of mass of the system. Its orbit is subject to constant gravitational perturbations, and the changing attraction of 2 neighboring stars significantly changes the plane of the orbit, causing cyclic oscillations. When the deviation reaches a maximum, the target leaves the field of view and then returns to it. Calculations show that the orbit of Kepler 413b changes with a period of about 11 years, deviating from the average value of 2.5 degrees in either direction. The planet's own rotation axis also changes its position significantly. Its maximum angle of inclination is 30 degrees. Combined with the marked eccentricity of the orbit and its periodic displacement, this results in a bizarre variation of climatic conditions on the surface. The region receiving the maximum amount of light from the parent star is constantly shifting from the equator to the poles and back again, resulting in dramatic temperature variations. It is likely that this process generates huge hurricanes of planetary scale, the size of which could exceed Jupiter's Great Red Spot. Air currents can carry ice clouds at a speed of several kilometers per second, gradually losing stability and collapsing. Meanwhile, collisions and deformation of vortices are capable of creating grandiose atmospheric emissions, which are able to overcome the gravity of the planet and reach the open space. According to calculations, they spend some time there before being pulled back by gravitational forces. All these incredible phenomena make the planet a very inhospitable place. But even that may seem like a peaceful island compared to the future world. 190 light-years from Earth. System environment HD 806-6. In the vicinity of this yellow dwarf, with parameters remarkably close to the Sun, is a planet with a very variable climate. Like a giant comet, it is rapidly approaching its main target, burned by the hot rays of its corona, or moving away to the periphery of the system. SE is a gas giant with 4 times the mass of Jupiter. The radius is slightly different from that of Jupiter. At the farthest point of its orbit, the planet is 0.88 AU away from its parent body and receives about as much heat from it as the Earth receives from the Sun. It is believed that at present, clouds consisting of water vapor droplets, ice crystals, or even quartz microparticles are condensed in its atmosphere. And the surface temperatures of the gas giant's hypothetical satellites can reach Earth-like values. However, as the planet approaches the star, its conditions change very quickly. In 55 days, the distance between the two decreases by a factor of almost 30. while the energy flow of the star increases by a factor of 800. Observations show that at the lowest point of its orbit, the temperature of the exoplanet increases about 2 times in just 6 hours, from 500 degrees to 1200 degrees. Such sudden changes lead to strong hurricanes that can reach speeds of up to 5 kilometers per second. The atmosphere of the gas giant absorbs an incredible amount of heat and expands so rapidly that it creates shock waves that can circle the entire planet several times. Water vapor breaks down into oxygen and hydrogen under the influence of temperature, and quartz crystals vaporize without leaving a trace, but then condense back into giant sand clouds. HD 80606b appears to be the only planet in its system. The gravity of another nearby star not only changed its orbit, but also brought chaos to the protoplanet's disk. Therefore, the chance of encountering large objects nearby is very small. However, destabilization of a planetary system due to the interaction of celestial bodies is not that rare. 1530 Earth color years. Neighboring regions of the Kepler-36 system. The central object of this system is a yellow subgiant. Its mass is close to the solar mass, and its radius is 62% larger than that of our star. 2 planets, a rocky super-Earth and a hot mini-Neptune, are orbiting rapidly around the star. Every 97 days they come critically close, only 1.9 million kilometers, about 20 times the minimum distance between Earth and Venus. At such times, their mutual attraction becomes the cause of global cataclysms. However, a few days pass and the celestial bodies diverge again until the next resonance. According to calculations, the gravitational interaction between the planets at their maximum approach is about 13 times greater than that between the Earth and the Moon. This effect should be particularly noticeable on the surface of the rocky planet. Its shell can crack and change under titanic forces. Incredibly powerful earthquakes occur. The resulting rifts can be hundreds of kilometers long and cause several giant volcanic eruptions. It is likely that some regions of the planet did not have time to cool down for such a short period of relative calm, and there is always a bubbling sea of hot magma. The reasons for the formation of such an unusual system are still controversial. It is now known that the super-Earth, named Kepler-36b, is located at a distance of 0.12 AU from its parent star and makes a complete revolution around it in 14 days. Its mass is 3.8 times the mass of the Earth, and its radius is 1.5 times the size of our planet. The object is calculated to have a temperature of 980 Kelvin, or just over 700 degrees Celsius, and its average density is about 30% higher than Earth's. Based on this information, it is suggested that the celestial body may be a Croton planet, the core of a gas giant that has lost its atmosphere. Such objects contain many heavy metals, such as iron and lead, as well as sulfur and silicon compounds. It is likely that the light elements that once formed the dense shell of the celestial body could have escaped into space under the influence of the stellar wind. Also, keep in mind the gravitational pull of another planet that can help the process. The name of this object is Kepler-36 Coulomb, and it is believed to belong to the category of hot mini-Neptunes. The celestial body moves in a nearly circular orbit with a radius of 0.13 AU and makes a complete revolution in 16 days. Its mass is 7 times larger than our planet, and its radius is 3.7 times larger than Earth. Because of its proximity, the temperature of the object is also very high at 928 Kelvin, or 655 degrees Celsius. According to current ideas about the structure of exoplanets, this celestial body is surrounded by a dense, multi-layered atmosphere composed mostly of nitrogen, hydrogen, and helium. As the depth increases, the pressure inside the gas shell increases, and it gradually turns into an ocean of supercritical fluid surrounding the solid core. Meanwhile, under certain conditions are possible and truly fantastic phenomena. For example, the gravity of a more massive planet has the potential to take satellites away from its smaller companion, and tidal stress can destroy them to form vast asteroid streams. In addition, the mutual gravitational influence of the two planets deforms their orbits, changing the eccentricity and other parameters. Because of this, the entire system behaves erratically and unpredictably, and its evolution cannot be calculated for any long time. Modeling shows that with 91% probability, both planets will collide with each other within the next 70 million years, generating hundreds of thousands of debris that will scatter throughout the planetary system, thereby further increasing the chaos within it. Perhaps such large-scale cataclysms have already happened more than once in a neighboring system. 434 light-years from Earth. 4 astronomical units from a young sun-like star is a stunning object informally known as Super Saturn. It is a brown dwarf, or a large gas giant, with a mass of about 20 Jupiters. Observations show that it is a young planet, about 15 to 16 million years old, and still forming. Most of its atmosphere consists of hydrogen and helium, and inside is a massive metallic core. This object is surrounded by a system of rings, much like Saturn, but of much more imposing size. No fewer than 37 distinct rings have been identified from the transit. In addition, the outer radius of the largest of them reaches about 0.6 AU. This is comparable to the size of the orbit of Venus, and about 640 times the radius of Saturn's rings. According to calculations, the total mass of the planet's circular disk exceeds that of Earth, and its behavior shows signs of chaos. Mathematical modeling shows that such structures are unstable and gradually collapse. Some of their particles lose speed and fall to the planet. Others, on the contrary, accelerate and leave the saucer for good. However, this process is much longer in time and may take several 100 million years. Also, in the system of rings was recorded a large gap with a radius of about 0.4 astronomical units, which is considered indirect evidence of the existence in this area of an exosatellite with a mass of about 80% of the Earth. According to modern ideas about the physics of cosmic bodies, it is such an object that is able to clear its orbit from small debris, forming a wide gap in the ring-shaped structure. In addition to him, observations indicate the presence of at least 2 more celestial bodies, each of which has a mass of about 30% of the Earth's and is located at a distance of about 0.25 astronomical units from the center of the brown dwarf. By analogy with known to us large planets, can be assumed that in total, within the gravitational influence of the central object, can be located several hundred exosatellites, including quite massive. Modeling of such a system, taking into account radiation from the parent star, heat flow from the giant planet, and tidal influences, shows that the temperature of its constituent celestial bodies can approach comfortable values. One can only imagine how fascinating the night sky is from the surface of such an exosatellite. At this distance, the brown dwarf occupies an area of the sky 70 times larger than the full moon, and its soft glow can dispel darkness and turn night into a hazy twilight. Instead of a multitude of stars, huge halos of light cross the planet's sky from horizon to horizon. At the same time, the ejective forces of a nearby massive body could cause many eruptions on the surface of the satellite, and its supposed ocean could cover the Earth with giant waves. The width of the tidal zone in such conditions can reach hundreds of kilometers, which allows us to consider it a unique climatic zone, something between the land and the ocean floor. However, it is worth remembering that such structures tend to be unstable and quickly change their appearance beyond recognition. At present, it is difficult to say how long we will be able to admire the giant rings and what will become of them in millions of years. Deep space is full of mysterious and surprising objects. They appear before us in the form of many photographs and a great deal of information, little by little revealing their secrets to all human curiosity. At the same time, each discovery raises new questions, and that means that the learning never ends.